learn together, pass together, grow together. So, today we learn tagging the network equipment. Okay, you just learned what a network is. So, what's our next move? Let's build one fast. That might feel a little backwards, right? Like, example or XYZ. Shouldn't we get way deeper into theory first? No, not yet. I want you see the physical pieces early because once you can picture how the gear connects, all the deeper concepts have somewhere to live in your brain. Here is the thing. In the real world, I almost never want to show up to the example server, crack open boxes on site, and hope genuine strikes in the moment. That's a recipe for catastrophe. Instead, I stage the network equipment first, meaning I set it all up at home, in the office, or on a workbench somewhere safe. Make sure it powers on. Make sure the cables are right and make sure the basic design works. Then when I get on the side, it's more like click, 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 boom, much smoother. Like I already practiced it before at the home, so it's gonna be easier for me to do on the on site. Okay, that tagging mindset is the big takeaway from this lesson. I'm not trying to make you rack and stack wizard in 5 minutes. I just you to start seeing the network as a collection of physical devices that get assembled with purpose, not chaos. Right? So, the first device I stage is usually the switch. Think of the switch as the core meeting place for the local network or the LAN, which just means the local area network inside our example server or example site. If we got resistors, wireless access points, cameras, servers, office PCs, all that stuff usually ends up plugging into switch some way, somehow. It's the thing that ties the internal network together. Okay, in the example I used a 24 port Cisco switch. Don't get hung up on the exact model number, okay? Seriously, don't. The important idea is that a switch has a bunch of Ethernet ports and each one gives me a place to plug in another network device. Okay? Now you might be thinking that why not just one giant switch and call it a day? Sometimes I do, but sometimes I don't. A lot of times I like having two switches instead of one larger. One because it gives me option for redundancy, which is just a fancy way of saying backup or resilience if something fails. Get my point? That said, this is where I have to check myself because networking loves trade offs. Two switches can help if one dies, okay, but they also mean if you now have two devices that could fail. I usually still lean towards having more than one device when it makes sense. My mindset is simple: two is one and one is none. Okay, if I only have one switch and it dies, I have got nothing. That's why I use two switches for better redundancy and for better working. If one dies, then another I have option, like a safer side. Okay, no, now if I do have two switches, I connect them together so they can share traffic. Back in the day, this used to be more annoying because you had to think about special crossover cables for certain switch to switch connection. Okay, these days most equipment uses auto MDIX, which means the switch figures out how to communicate over the cable automatically. In plain English, we said modern switches are a lot smarter and life is better. Okay, once the switch are connected, I start plugging in the other pieces of local network. A server goes into the switch, In my example, I showed a little box that could do things like store files or run media. But the bigger point is this: servers provide service to the rest of the network. Client like laptop or tablet consume those services. Okay, then I add the wireless access point, which is the device that takes the wired network and extend it into the air. That's how phones, laptops, and tablets join the network over Wi-Fi. And I love this part because it's such a simple visual, right? One cable into the switch, mount the access point somewhere central of the example site, and now our network isn't just in a cable, it's all around the room because of the Wi-Fi or because of the WAN, which is VAPW, because of the VAP, which is wireless access point. Sorry, hang on. You will often see different Ethernet cable colors in labs and production networks, and people sometimes assume the colors means something magical. It doesn't. Not inherently. We use different colors for organization, which is wigged cool and super helpful. But a blue cable isn't more server than a yellow cable just because it's blue. Okay? I think you got confused. I also. So don't worry. Okay? You will understand a bit later. Here is the piece that changes everything, which is the router. The switches, the server, and access point can all create a perfectly fictional or functional local network, but none of that automatically gives us internet access. That's where the router comes in. Here is the piece that changes everything, which is router. The switches, servers, and access point can all create a perfectly functional local network, but none of that automatically gives us internet access. That's where the router comes in. The router is a device that connects our local network at example site to the outside world, the WAN or wide area network, which is in the case in the internet. Okay, so one side of the router connects to our switch, meaning it joins the local network, and the other side connects to whatever service brings internet into the building. Maybe cable, fiber, DSL, or some kind of wireless handoffs. That upstream provider is the ISP, Internet Service Provider. They are the company actually delivering the connection. And this is also where a lot of our protection lives. The router is often where we put firewall rules and filtering, meaning it can decide what traffic gets in and what goes out and what should be blocked. I know, there is a lot more that here. I can feel myself wanting to run off into a whole lesson on routing and security. Not it. For now, I just wanted to see where the internet enters the picture. Okay, so this whole lesson really comes down to one best practice. Don't build the network for the first time on site. Okay, that's where surprise gets expensive. Maybe the access point doesn't power up. Maybe the switchboard you plan to use is bad. Maybe the router isn't configured the way you thought. Those are minor annoyances in a live example side with customer waiting. That's pain. And remember, the physical distance is the final install can be much longer than what you are seeing on your desk. Okay, in the example site, cables may run through ceiling and walls back to an MDF, which stands for main distribution faculty. Basically, the central location where the network gear lives. In staging, I compress all of that into a tabletop version so I can prove the design works before I deal with ladders, drywall, and real world nonsense. Let me put this all together. Okay? The switch ties the local network together. The server plugs into the local network and provides services. The wireless access point extends that network over Wi-Fi. The router connects that whole internet world through the internet. That's the physical picture I want in your mind. Okay? So, if you walk away remembering only few things, make it this. Stage first because it is the safest place to catch mistakes. The switch is the center of the local wired network. The wireless access points extends that network into air. The router connects the local network to the internet, and multiple switches can add flexibility and redundancy, but they also add design decision. Okay, that's enough for now. Seriously, I don't want you to bury under 20 layers of networking jargon, or when what you need first is a clear mental picture of how the gear fits together. Once that picture is in a place, the deeper stuff starts making a lot more sense. Okay?